All right, everyone. Good afternoon. I think we're going to go ahead and get started. I'm going to share with you a little bit about how to use LOINC with FHIR today. And I'm excited about that. Just a couple things about me. So first, by clinical training, I'm a physical therapist and also a medical informatics person, which is a little bit of an unusual combination. I've been leading the LOINC work at Regenstrief now for a little over 10 years or so much so that at places like this, I get introduced all the time as the LOINC guy. So you can call me that, that's fine. But if you want something else more interesting to talk about, you can ask me about a philanthropic side gig called the Pocket Square Project that I just started up. By way of disclosure, a couple things to mention. One, I'm part of a company that published a book about LOINC, and I'm PI on most of the LOINC-related funding activities, some of which are from commercial sources, but the vast majority of LOINC work is funded by federal and other nonprofit things. And especially the FHIR-related LOINC work coming from support from the National Library of Medicine and the Office of the National Coordinator. So what I'm going to share with you today is a little bit about how FHIR and LOINC go together like chips and salsa. What I mean by that is that FHIR is like the perfect delivery vehicle for LOINC-coded goodness, i.e. the salsa. And I'm going to try to do that by talking about sort of three things. We're going to try to cover just a brief background about what LOINC is all about. Two, we're going to cover some places within FHIR that you are likely to encounter LOINC or could use LOINC. And then three, I'm going to talk about some of the LOINC-specific FHIR terminology services capabilities that are available. And so especially this portion of the talk will follow quite nicely in with some of the other sessions in the terminology track. So there were sessions on SNOMED earlier on, and then this morning Jim Steele gave a really nice introduction to some of the terminology services resources that are in FHIR, and we'll be illustrating some of those with LOINC stuff at the end of this. So if you're following along and want to do some sort of take-home exercises, or while we talk exercises, there should be a link from the conference website. You can also get that from my website, just myname.com/FHIR, and that'll take you to the exercises for this. As we get rolling, I wanted to do just a quick sense of those of you who are here in the room. How many of you would say that you're pretty new when it comes to LOINC? Your level of familiarity with LOINC is like kind of baseline, pretty new. All right, so a good number of you. How many would you say relatively new? Okay, good. How many of you would say you're like an advanced expert LOINCer, so to speak? All right, so a handful. Great. We got a good mix here. So I want to start by telling you just a little bit about what LOINC is all about, how it came to be. So if you're not using LOINC and you're trying to aggregate data, you run into things like this all the time, this is sort of the state of clinical systems around the central Indiana area where I come from. Back in the mid-90s when we were trying to build a health information exchange, we were gathering as much data as we could, trying to put it together. And what you realize is that inside of all these different systems, the same clinical data is called all different sorts of things. So this is just one particular super common measurement, right? Diastolic blood pressure. And there's all different codes and names and strings for this. And it doesn't matter if we're talking about blood pressure or other vitals, you're talking about each lab test, you're talking about radiology procedures or anything. The more data you're trying to pull together, the more you run into challenges like this. So back in the mid-90s, there was no standard available that was covering this kind of thing. And so what I wanted to illustrate to you was that we're hearing lots and lots and lots about FHIR, and FHIR is amazing. It fulfills a particular purpose, but FHIR plus standard terminology is what is really going to sort of get us across the finish line, and they solve sort of different parts of the interoperability puzzle. So whether you're using resources in FHIR or even some of the other HL7 standards or common data models, combining that with semantic standards such as coding systems, and we're going to talk a lot about LOINC, but for other purposes, there are other relevant coding systems as well. Those two things together are what's going to make it really possible to reuse and act on clinical data. So I mentioned we were sort of trying to piece this stuff together, and at the time, back in the mid-90s, there wasn't a coding system or terminology that really covered this space, and so LOINC was born to try to be the universal standard for identifying health measurements, observations, and documents. And the intent, and the sort of level of granularity at which LOINC wants to create codes is that we want the terms to have the specificity that are needed to distinguish among clinically important differences, meaning this is sort of what set us apart from some of the, say, billing or administrative terminologies that were in play at the time. So the idea is, right, we need these standard codes so that we can pick out things that have similar names but different meanings. So we're trying to pick out the meerkat from amidst the meerkats. So LOINC is, in summary, sort of this freely available global terminology standard. We package it up with a set of rich implementation tools, one of which is now sort of the API capabilities via FHIR. But LOINC is more than just sort of that content. It's more than just sort of the database or the standard list of codes. It's used by a diverse global community, and just like FHIR, it's that diverse global community that continues to propel LOINC's ongoing development. So all of the new additions to the coding system that have happened in the 25-year history of LOINC are done by end users who are looking to link their local codes to LOINC and then finding gaps, making requests, and we continue to add to the terminology. Our approach to developing LOINC is guided by a set of principles that you can see listed here. I'm excited we've sort of crystallized this into our new manifesto that you can follow the link from the slide and dig into a little bit more about the guiding principles and thought process behind the development of LOINC. But specifically, from the beginning, LOINC's main purpose was to fulfill this job of being the universal sort of observation identifier. So it's designed to work equally well, sort of in any context where you have one part where you're trying to identify what the test or measurement is, and then another part where you're going to say what the actual result value is, and probably associated with its units of measure. So any structure that has sort of that key value pair for recording observations, you can use LOINC to identify that observation. And of course, in this particular context, conference like this, we're really focused on FHIR, which is one very nice way to do that. If you have heard about LOINC, you probably have heard about it in the context of laboratory tests and or perhaps vital signs. What you might not realize is that it covers a pretty wide space of things. So I like to say it's like this rich trove now of almost 90,000 standardized variables. And if you're thinking about sort of the healthcare space from like a precision medicine landscape, you think of things all the way down to the molecular and genetic level, up through our normal sort of clinical variables, and all the way up to information that we want to record about the environment. LOINC sort of covers that entire landscape of stuff. So certainly there's a huge set of codes around molecular pathology, genomic reporting. If you listen to some of the sessions on clinical genomics, you'll see what role LOINC plays there. The traditional sort of laboratory clinical measurements, but also things such as clinical notes, report titles, radiology procedures, but even things such as lifestyle variables, activity measurements, etc. Or things where the unit of analysis is not a person, but potentially a population or a collection, perhaps a neighborhood, a block, a census block, etc. All those things sort of are observations that we represent within LOINC. So today, that broad user community has grown quite substantially to the point where there are now hundreds of millions of patients with billions of discrete results stored in systems around the world that are coded with LOINC. So I want to give just like a little bit of a deeper dive. We're not going to go like way down to the bottom here, but just a little bit of a dive about what a LOINC term sort of is made of. What are the kinds of things that you can find in LOINC? So I'm going to use sort of an example of a hematocrit. And so a LOINC term consists of a code, a unique identifier, and then a structured name. That structured name has 5 or optionally 6 sort of attributes to it that make up the sort of unique distinction for that particular term. Those attributes are the component, which represents the analyte, the substance, the thing that's being measured. The property, which is designating the kind of attribute that's being measured about that substance. So in this case, it's a volume fraction. A timing, whether this is a point-in-time measurement or some aggregation, say a 24-hour urine collection type of thing. The system, which is often sort of the specimen in a laboratory test that this measurement is made upon. The scale, which helps distinguish things that are quantitative from things that are categorical or ordinal in nature. And then the last attribute there, the method, is the one that is optional. And we use that to make distinctions between things that would have a difference of clinical interpretation. So 6 major axes, and we assign identifiers called parts. So LOINC parts, they have the prefix that starts there, LP, to each of those attribute values. In addition to the primary name, which is sort of the concatenation of those 6 attributes, we call that the fully specified name, we also can link up and develop a number of other sort of names that are associated with that code to make up the term. The primary display text that you'll see in a lot of FHIR resources is the long common name. We also have a name that's sort of more provider-friendly called the display name. And our newest iteration in our upcoming release will have a broader collection of names specifically designed for view by consumers. So LOINC creates codes for observations, which would be individual tests and measurements, body weight, step count, blood glucose, etc. But it also creates codes for collections of those things. And we kind of distinguish 2 kinds of collections in LOINC. The first we call panels. In a panel, we use that word kind of generically. It represents an enumerated collection of individual variables. So if you think of, from a lab context, you think of a CBC, that has inside of it a number of different components. But we give a code to the CBC with autodiff and then link up an enumerated list of child elements. That's what we label as sort of a panel within LOINC and have a model for representing that. But we also have codes that represent other kinds of collections that are just not enumerated in full. So these are sort of the codes that represent documents, such as a discharge summary. And there might be lots of different sort of potential configurations for the kind of information that's in there. But that is left up to sort of implementers who design implementation guides or profiles that lay that out. From LOINC's perspective, we just label that document at a high level. And then the last kind of code I think I wanted to mention was that we do create codes for some kinds of answer options. So the things that would appear as result values or observation values in categorical or ordinal responses. And this was particularly important for representing survey instruments or other kind of patient assessment instruments where the set of allowed answer options was very closely linked to what the real meaning of that particular question was all about. So we package up the release content in 2 new versions that happen twice per year. We're just a week or 2 away from our June release, and we'll have another one in December. As I mentioned, we have a whole collection of release artifacts and implementation tools that are distributed with it. But importantly, I wanted to mention a couple things about the LOINC license, which lets you know how you can use LOINC. Obviously, one of the most important things is that it's available at no cost worldwide, sort of anywhere, in perpetuity for both commercial and non-commercial purposes. It allows redistribution, it encourages translation. Really the most important thing you need to know from a license as far as what you cannot do is that you just can't use LOINC or any of the related licensed material to make a different standard for the same purpose that LOINC was designed for. So you can't use LOINC to make a different standard for orders and observations because that sort of defeats the whole purpose of having a universal language. Now, you've seen a couple of examples on my slides thus far, and if you hang around LOINC land for a little while, you'll see this little pig, and you're like, what's the deal with the pig? And basically, it's just for fun. This is our unofficial mascot because LOINC sounds like oink, which is the sound that a pig makes. And so we've adopted that as our mascot. If you want a little sticker that looks like this, come find me at some point during the conference. So now I'd like to share a little bit, just a brief tour of where you're going to see LOINC out in the wild. You know, where might you encounter the spotted LOINC leopard there in the FHIR jungle? Well, obviously the first place you'll probably think of is over in the diagnostic medicine module, where we're talking about the observation resource, of course. Right, so LOINC is a widely used, probably the most widely used code system for observations. And so when you have an observation and you want to sort of report a classic sort of quantitative result, you'll use a LOINC code to identify the test or the measurement that's being done, and then over in the value quantity space, you'll have the actual result value with UCOM units coded up there. So here, you see the place where you'd find sort of the hemoglobin or other observation code in that resource. Now, if you want to use that information, you can say, all right, I can say, give me the hemoglobin observation for my patient, so I can pass the patient ID and say, give me back, the observation that is identified with that code. Or, you can use reverse chaining and kind of do the reverse and say, well, show me all patients that have hemoglobin as an observation. And so you can use a syntax like this to reverse chain and get back the list of patient resources that contain this particular test result. The same model works great, if you're using coded or ordinal response values, for example. And here I show you an example of a CYP2C9 gene product metabolic activity interpretation, where what we're trying to communicate in the response value is that this patient is a normal metabolizer. And so you can use sort of a coded representation of that answer choice as the value for the observation as well. So we got LOINC codes at the top and then answer codes in the bottom. And of course, many different kinds of profiles are being developed that sort of further constrain that base observation resource, that may identify a particular LOINC code for a sort of more narrow use. Some examples would include the profiles contained in the sort of clinical genomic space, or the vital signs profile, for example, that links up specific LOINC codes to particular vital sign observations. But I mentioned, this other characteristic of LOINC codes being designed for collections, and so one of those kinds of collector terms would be diagnostic studies or imaging reports. And so in these resources, that's where you've got codes that represent diagnostic services, whether those are pathology or radiology, et cetera. And LOINC is a recommended or preferred coding set for that. And in particular, for the imaging studies and sort of radiology reports, there's a special section of LOINC called the LOINC RSNA playbook that's perfect for radiology procedures. And this is an approach to modeling this content that was jointly developed between the model that LOINC had and the Radiologic Society of North America, and is an ongoing partnership there. So I've got a link to that set of codes in there as well. Outside of that area, in the foundation model, you might encounter LOINC quite a bit, or want to use LOINC in the questionnaire resource. So questionnaire designs sort of the form or the assessment instrument. Questionnaire response can store the result values or the instances of a particular form that's been filled out. And LOINC has a really rich data model for representing the collections, the data elements, which might represent the questions, how they're organized into an overall instrument with sections, and then linked up to their answer list. And so LOINC can really form a nice backbone for constructing questionnaire resources. And I've given a couple of examples here, one from, say, the U.S. Surgeon General Family Health Portrait instrument. And you can see sort of the breakdown of, there's a code for the top level that names the instrument. There's codes for individual items and answer choices as well. This has actually been a super hot area of development of LOINC over the last few years, we probably have more than 10,000 or so individual codes that are related to assessment instruments and these collections and so forth. And I've listed here just a few examples, the PROMIS instrument, the PHQ-9 and 2 and so forth. So this is sort of a rich area of content within LOINC. In addition, composition and document references are other ways to bundle things together. And so, composition refers to sort of the structure. Document reference would be a reference to a document. And as I mentioned, LOINC has a really rich set of clinical document type and section codes that if you're coming or familiar with CDA, you might have encountered those as well. Their equivalents or representation structures in FHIR use them in the same way. But for example, identifying discharge summaries, progress notes, and the like. Both at the sort of overall document level and at the level of sections within those documents. All right, so that's kind of like the key main set of things where you might encounter LOINC within FHIR. I just want to give like a quick snapshot of here, a few little samples of how having FHIR and LOINC together can do some cool things. So for example, you've probably seen a variety of different sort of smart on FHIR apps that are designed around improving clinical decision making that provides CDS. And many of them, here's an example that is going to help predict cardiovascular risk based on some guidelines. And if you sort of look inside about how do they calculate this risk in a way that works across multiple electronic health record systems, well, the way in which, for example, the laboratory tests that go into that risk score are identified in the algorithm is essentially by using LOINC codes, right? So this is a way that you can make it possible where if the source data system is mapped or linked to LOINC codes, this particular app is going to work and run in any of those different contexts. I mentioned this sort of structure, this data model for representing forms and assessment instruments that LOINC has. And by starting with sort of that universal catalog and a sort of systematic, uniform way of representing that information, it makes it possible to build pretty easily apps such as the LHC Forms tool that sort of automatically render a data input screen based on that sort of panel or form definition. So this is an open source JavaScript toolkit called LHC Forms that does just that. It sort of reads the LOINC panel definition and automatically sort of populates this, including sort of the allowed answer choices and sort of the ordering, et cetera, based on the LOINC representation of this particular instrument. It's showing an example of the adverse childhood experience set. And then, of course, there are many sort of examples of sort of pulling data together from different sources. And I'm sure you're familiar with the Apple Health Records app and sort of how that leverages the Argonaut FHIR profile, which requires LOINC codes for lab tests and other vital signs. And so that's sort of the way in which we can pull together disparate data from multiple health organizations and link it together at the level of the individual tests. So inside there is sort of secretly identifying the measurements, LOINC codes. All right, in the last part, I'd like to sort of cover some of the LOINC-specific FHIR terminology services. And this is sort of where the examples from the exercise kick in. And the way that we're doing that via the terminology services that LOINC hosts is using HappyFHIR via the Smile CDR product. So what does this do? Well, it makes it a lot easier to do things with terminologies than we could before. And we're using three of the main sort of terminology resources. There's a nice write-up of this if you want more detail on the LOINC website, loinc.org/FHIR. It kind of gives you the landing point for what content is available in these resources. I'm going to give you sort of the highlights of it. So we use the code system resource, we use the value set resource, and we use the concept map resource. And so for those of you who were at Jim's session, you've got a great overview of what those resources contain and some of the operations there. We'll start with the code system. So we sort of co-developed with the FHIR community a canonical representation of LOINC as a code system that's available at the URL there. And what it sort of lays out is how does LOINC and its specific sort of attributes, I described to you sort of the way in which a LOINC term name has a structured set of attributes. How are those represented in the code system, and then what can you do with that? So the canonical definition for that you can get here. And briefly what it means is when you're using LOINC codes, use the URI, http://loinc.org, and then inside that code system are a couple different kinds of codes. So there's the main LOINC terms, there's the parts that I mentioned that make up those attribute values, there's codes that represent answer lists or collections of individual answers, which are labeled with LA codes. And then inside there for the LOINC terms, the display names that we use are that long common name. But for each LOINC term, main term that's in there, there's sort of a basic set of properties which include the sort of formal semantic model pieces of it, and some key metadata attributes, the term status, whether it's active or retired, its class, and a few other bits. We also have another set of properties that are available. For example, you can look at the LOINC term and say what answer list is associated with this term. There are a couple of special properties to support the HL7 attachments work, sort of the exchange of information between payers and providers. And then we have more detailed attributes that represent these two other specialized domains, radiology procedures and the clinical documents, where we have an extended set of properties to represent those models. So all of that is sort of available in the code system resource. And if you just want to use the lookup operation to get all that information about your favorite LOINC term, you can just sort of pass the base URL, code system, and then look up using the URI for the system and the code that you're interested in as two parts there. And what you'll get back is the entry for that particular LOINC term. And of course, I've truncated this on the screen, but you'll get all those different properties that I laid out as being part of the code system back from the server when you pass that response. So that's code system. You can get lots of detailed information, look up codes that are in the LOINC system. What about value set? So we use the value set resource to accomplish a couple of different things. One is we make every LOINC answer list available as a value set. So I mentioned that those things get identifiers. We call them, we give them an ID that starts with LL for LOINC list. And so we use that pattern as the sort of URI for the value set for that answer list. And so if you want to do that, you can pass the LL code as part of the parameter or part of the URL string, and then use the expand operation, and you'll get back the list of items, the LA codes that comprise that LOINC answer list. And so I don't actually recall what specific example this is, but the first item in the answer list is none. There you go. So we got LOINC answer lists. You can get those as value sets. We also make some key subsets of the overall LOINC terminology available as value sets. The LOINC FHIR webpage lists which ones of these, or you can query the server to get them. As one example, the subset of LOINC terms that make up the LOINC RSNA radiology playbook is one subset that you can grab all at once. You can also grab the document ontology. You can grab the top 2,000 common lab test results, et cetera. So you can get that value set by querying, if you know, for example, the URI that identifies that value set, and you'll get back sort of the list of things, the list of LOINC terms that make up that value set or the value set definition. But you can also build your own collections of LOINC codes based on the properties that are available in the code system. So that's why I sort of described sort of each of those individual attributes. What can you do with it? Well, say you wanted to pull together the set of LOINC terms that were measuring or had something to do with West Nile virus. So you can make a little value set definition that relied on or specified the set of terms that were in there using those LOINC properties. So we say, well, we want ones that have the component of West Nile virus, And we don't really care what the specimen is, except for our purpose, we want to exclude specimens that have to do with the fetus or donors or blood product units. And so we can use both the include portion of the composition statement and the exclude portion to sort of narrow down what we want. And here I'm showing an example using just a regular expression, sort of string matching. You can also use the sort of coded attributes of the LOINC parts to make up these kinds of value set definitions. And then when I run sort of the expand operation, the server is going to go back and it's going to sort of match that definition against the codes that are in the code system resource and come back in its expansion with the collection of individual terms that make up that list. So here you see sort of an example of some of the West Nile virus terms. There's another effort that's a relatively recent iteration in LOINC world, which is called LOINC groups. And I'll point you to the website there if you want to learn more about it. But the idea is we wanted to programmatically create smaller subsets of LOINC codes that could be treated as equivalent for a particular purpose. So there are times when, for your use case, you don't necessarily care whether this was done by an automated machine, a manual count, or it was methodless, meaning it didn't specify what the method was. And so we've sort of built out these little collections of LOINC codes that we call groups and make them available as a release artifact. But we also make each one of those groups available as value sets that you can query against using the API. So here is an example, the LOINC group that pulls together all of the body weight terms regardless of their method. And so if you use that LG code, which is part of the identification of the value set, what you get back is the list of LOINC codes that are body weight measurements that pull together whether it was a stated body weight, a measured body weight, or we don't know what it was. So the last terminology resource that I want to mention is the concept map resource. And so the concept map resource links, has sort of a structured connection between codes in one code system and codes in another. And as part of the LOINC distribution, we officially publish a couple of different kinds of mappings to other terminologies. There's a vetted list of LOINC terms that are linked to IEEE codes. There's a linkage between LOINC radiology terms and the corresponding RPID code from RADLEX, which is the RADLEX procedure ID. Those two link LOINC terms to other vocabularies. And then we also have a couple of collections of LOINC parts that are linked to external sources such as PubChem, RADLEX, RxNorm, etc. So the concept map resource works to sort of define those collections. And if you want to, for example, get the linkage or the mapping between LOINC codes to IEEE codes, you can pass that concept map identifier to it in the server or sort of pull back that resource. And what you see there is sort of at the bottom, you've got sort of the LOINC code identified, and then the target code is the code from IEEE that is linked up to it, and an equivalence designation saying that these two things are sort of exact matches or that they're equal. And you can use the other concept map resources to sort of say, hey, do you have a mapping for this particular code? If so, bring it back to me, etc. So, take-home lesson here is, clinical data that's coded with LOINC and made accessible by FHIR is awesome because diverse IT applications can actually understand it, can interact with it, and can do so for the benefit of many in the health ecosystem. So I try to leave some time for questions. I think we've got some, but I'll close by saying happy LOINCing. All right. So I think we've got about 5 minutes or so. Any questions? Yeah. So the question was, can you query code system or value sets and get back display text in other languages? We have not implemented that on our FHIR server, but absolutely yes, it's possible. So technically, There are a couple of different sort of techniques for doing that as designations or as code system supplements, which is sort of the other use case. There's some discussion about how exactly is the best way to do that, but specifically for the LOINC release content, we haven't put that into our server yet. Yeah.
The search functionality on the website, you can translate and there you get the results. That has to be done manually.
Yes, exactly. Yes. So it is on our to-do list. Yes. Cool. Yeah.
LOINC is one of the most worthy authoritative sources.
Yeah. So there are three possibilities for what you might want to use. So the name that will exist for every concept that's in LOINC that's sort of more clinician focused would be sort of the long common name. But the better one is the one that's more close to what you would likely find on a lab report for clinicians is called our display name. So there's actually a separate downloadable artifact. We've iterated a few times on the rules we use to construct those names, but it covers all the lab tests. It doesn't cover all the other parts of LOINC. So that's one. As I mentioned, our latest brand newest initiative is for consumer-facing names, and that will be available in our next release as a separate download. So look for the thing that's called consumer name there. Yeah. By the way, coming up with acceptable names that everyone agrees to is one of the most fun things you could possibly ever try to do. Yeah. Other questions? Yeah.
Is there any overlap between the LOINC codes and the new ASCO M code that's just now emerging? Is there going to be some kind of harmonization?
Yeah, great question. So I haven't been directly involved in that, but I would assume, like other efforts to create sort of common data elements, there are a couple of sort of aspects that go into that. But one of them is typically linking the idea of what that data element is to a standard coded representation. And so while we haven't talked to them, I would expect that they would be looking at LOINC for identifying those kinds of things, whether they're lab tests or vital signs or other kinds of clinical measurements. But we could poke around at their IG and see if they're on that path already, but I don't know the answer. Yeah. Yeah, sorry. Question there, yeah.
Are you familiar with solar, and is there plans to integrate LOINC in solar?
I'm familiar with two kinds of solar, three maybe, but two related to informatics. And I don't think you're talking about Apache Solar, the search indexing tool. We like that too. We use it. I think you're referring to the sort of I think it changed its name, but it was originally sort of SNOMED, LOINC, RxNorm integration, Keith Campbell's work, et cetera. And the idea behind Solar is to kind of put in one semantic model those three terminologies and build sort of linkages between them. The backbone of sort of the way that sort of integration is working uses the SNOMED CT concept model. And there is, LOINC has had a collaboration agreement with SNOMED International for a number of years, and we've, to some extent, to a subset of LOINC terms, built sort of pathways that let the LOINC model relate to the SNOMED observables model. They're not exactly the same. They're sort of they were informed by each other, or SNOMED's observables model was informed by the LOINC structure, but they're slightly different. And so there isn't like a complete integration, but it was sort of, Solar was made possible by that connection between those two terminologies. So I would say it's sort of a work in progress, but is a little bit different because it's the sort of SNOMED view of what the LOINC observable stuff is. Yep. Yeah. All right. I think we're good. All right, thank you.